So we have an improper integral here because between our limits of integration, we are going to come across 0, and 0 here causes our integrand to become unbounded. So this is actually going to be 2 steps to turning this into a proper integral. First thing, we got to split it into 2. We're going to go from -2 to 0. And you could do this all in one step. I just want you to see it. 1 over x squared dx plus 0 to 2, 1 over x squared dx. And what we end up with is basically 2 improper integrals that we are going to have to do separately. If one of them diverges, the whole thing diverges and we're done. So let's rewrite these as proper integrals with limits. So limit as b goes to 0, remember it comes from inside the interval, so it's coming from the left on this one, of -2 to b, and let's write this as x to the -2 because we're going to be taking the derivative, antiderivative, excuse me, plus limit as a goes to 0 from the right, a to 2 of x to the -2 dx. Nice part is they both had the same antiderivative, so it's not like it's a whole lot of extra work. Limit as b goes to 0 from the left, this is going to be -1 over x is the antiderivative from -2 to b, plus limit as a goes to 0 from the right of -1 over x from a to 2. I'm going to go ahead and plug in our limits, but you might already see what's going to happen. When we go to 0 from the left or from the right, both of these are going to blow up to infinity. But just to finish our structure here, limit as b goes to 0 from the left, I plug in my limits, so -1 over b minus -1 over -2 plus limit as a goes to 0 from the right of -1 over 2 minus 1 over a. So as b goes to 0 from the left, -1 over b actually goes to, as we go to 0 from the left, so if we're looking at 1 over b, this goes to negative infinity. And as we go from 0 to the right, 1 over a goes to positive infinity. So it turns out both of these diverge. It only takes one of them. But this improper integral diverges.